Welcome to the second lecture of Agentic AI for PCB design. Let's get started. So in this lecture, I'm going to show you how to, with the help of Agentic AI, how you can derive technical requirements from customer needs. Often this is pretty challenging because customer needs, they often directly from customer interviews, they are ambiguous. There are a lot of the fuzzy stuff you need to deal with, but the requirements, they need to be technical. They need to be often preferably quantifiable. So you can actually verify later in the design stage. In embedded system design courses I've been teaching, I often ask students to spend 1 or 2 weeks to talk to a customer and also do some market research for this purpose. So here, I want to show you how to use agentic AI to accelerate the discovery. So first of all, just a recap of the example I mentioned in the first video, which is we want to design a mobile robot sensing system that can be used for underground pipe inspection. And I would like to show you what I want to show you that the process of deriving requirements from user needs is equivalent to making a whole bunch of decisions using your engineering judgment. So I would say this is probably the area where we might find it's most difficult for the AI to replace humans because there's actually no right or wrong answers. In a lot of cases, making the right decision to me, it occurs to me, it's more like it's more of the art than science or engineering. You really need to use your instinct. You need to use your judgment. You need to have a good taste. Of course, those should be built upon a deep understanding of the market, deep understanding of user needs, which is something that AI agent can help you with. Let's say you work with a contractor who asks you to design this robot for underground pipes inspection. But there are still a lot of questions you need to answer before you can proceed. For example, what kind of pipes we build this for? Is this for sewer? Is this for cable conduit? Is this for gas or for water? What kind of sizes we'll talk about? Here, the DN means diameter. So DN 100 means the pipe has the underground pipes has a diameter of 100 millimeters. And which problem I try to solve? Is it just for damage detection for the pipe, or it's also for blockage cleaning, which is very, very different. Also sets of different requirements for the mobile sensing robot. That's your PCB. And most importantly, who's going to pay for that? Is it homeowner, contractor, utility providers? So you need to answer all of these questions to derive requirements. So what I often do is that I will ask AI agent to do some synthesis. So as you can imagine, the LLM, the large language model, it builds on will do the research, leverage market reports, academic paper, product data sheets, industrial standards, or even the websites of competitors who may sell similar products, and it will synthesis into reports. So this is one example reports that my agent gave to me. I should admit that before that, I literally have no idea of this market. But as you can see, the agent actually gave me some useful insights. I should clarify that there could be factual mistake or errors, or even this can be all wrong. What the agent can tell you can be all wrong. We all aware of this hallucination issues by most large language models, but it's totally okay because the purpose of these videos are just show you the process, how as a human engineer can collaborate with your agent. For example, the agent tells me there actually exists a niche market where we almost face less or even no competitors. If we can build a product that target a pipeline with a diameter of less than 100 millimeters, and if we can build a product that has a higher autonomy level that can drive itself back and forth within the pipe, and it also give me a better view of at which stage of in the construction project this type of product can be applied. So these are they're actually much more. One example, for example, my agent actually gave me a report of 140 pages, but what I'm trying to say is that these information can be very useful for later on decision making. So as I mentioned in the first video, the agent doesn't like natural language, so you can ask it to translate it into a markdown file or other file format that is more friendly to agent to machine readable. So with this market summary, this markdown file generated by agent, you can actually build a multi-agent team to drive the decision making, drive the requirement generation process. Here, I'm showing you an example of a multi-agent team where orchestrator agent is trying to coordinate with multiple sub-agents. Each of them responsible for a given aspect. They have their different design artifact, have their own log, have their own regardless of its markdown file or YAML file. The whole point is that the agent team actually help you to ensure the traceability throughout the decision-making process to create requirements. So here, I want to give an example of how this multi-agent team might look like. For those of you who actually used agent tools earlier, for example, let's say OpenClaw, you might find this workspace, this folder, familiar because as you can see here, this is a very typical workspace by multi-agent team. Let's say we have this sewer robot PCB design agent. Here we have a file called agents.md, which is actually the file that describes the roles and responsibility of this main agent. In this case, the orchestrator agent that coordinate different sub-agents. For example, you can have market research agent, which I already use, agent responsible requirements for creating schematic, for layout, for whatever stages. And also it has a whole bunch of skills it can call, a concept we're gonna talk more in detail later. But here, think of a skill is kind of like something that wrap up a whole bunch of function or codes, so you don't need to worry about the details. For example, we can have a skill to have the agent talk to KiCad, which is the open source EDA tool we're going to use for illustration purposes throughout this course to create a schematic. We can have a skill to derive power budget based on the component we selected, and we can have a skill to automatically create design rule checks for manufacturability checks. Also, the agent has its own memory, and we can also have subfolders for different individual workspace for different agent. The whole point here is that you don't want their memory to interfere with each other. And the concept of memory is also very important, and we're going to talk about it later in this course. So let's see how exactly the agent, with the help of agent, the agent can help you ensure the traceability throughout the decision-making process. let's say you make 3 decisions. These 3 decisions. The first one is you want this product to target the residential sewer lateral with a diameter of 100 millimeters. So here I'm giving you a visualization. As you can see, this is what I call a residential sewer lateral. It actually connects the pipes from residential buildings to the sewage system owned by public agencies. So as you can imagine, neither it is the focus. The house owner will pay less attention, neither nor the public agencies focus. But the point here is that it actually gives you more idea. The market analysis done by agent actually can give you more idea of what exact usage scenario for your product. And this actually give you a more idea of who is your customer, who is going to pay for that. So here, let's say the second decision you make is we want to sell this product to a general contractor. And this is also this decision can also be driven by the market analysis, the willingness to pay. So for my agent, it actually tells me, well, there's actually a standardization body called a NASCO in this case, who try to provide a whole bunch of certification program for underground pipe inspection. So this actually gives the contractor some motivation to pay for that, because if you can help the contractor to inspect to find any defect without digging up the pipes, it actually save a lot of money and time for the contractor, so they can have more motivation to invest in your product. Of course, for those of you, you can check, and you should check whether there exists a standardization body called a NASCO, and you should also check how exactly this residential sewer lateral looks like in real. But because of the hallucination issue I mentioned, there actually a technique in agentic AI field we can leverage to tackle this hallucination. For example, RAG, retrieval augmented generation, or you can have the agent to reflect to do more check before it give you the answer. But here, as I said, it matters less in our context, because I just want to show you how the process works. And you can make the third decision regarding you want your mobile robot to have 3 functionalities, including so in addition to a small pipeline, you want to have certain level of autonomy such that it can drive itself back and forth within the pipe. And you also want to have some kind of onboard AI for damage detection to add more market differentiation. So these are decisions you can make based on the market evidence provided by your agent. And of course, you can always ask the agent to translate these decision-making process into to serialize it, to write it down into a file format that is machine readable. So to further visualize this process, so based on the market evidence, you as an engineer make the decision. You can verbally tell the agent, or you can just write it down. The agent and another agent responsible for the requirements can translate into a design decision log. Not only it includes the ID for reference for tracking, but also the rationale as to why you make this decision, what are the alternatives. But here, as I mentioned earlier, what I want to address here is that you as engineers, you still need to do a homework and make the decision. The agent can only help you to the extent it can, to the extent that it gives you enough evidence, provide you enough information to build up confidence. But as an engineer, you still need to make the decision. You are the ultimate problem owners. You are the manager. You are the boss. So the first decision you have to make is, as we mentioned, which usage scenario. In this case, maybe you make decision that's target the pipe for a residential sewer lateral. Maybe you come up with 4 different criteria, including willingness to pay, regulatory anchor, whether there's exists enough economy stake, whether the level of autonomy the agent should have, and you can ask the agent to do the ranking automatically based on the market analysis it generates. The process can be automated. And it can give you, so obviously in this case, the highest score wins, in this case, residential sewer lateral. But here you still need to tell the agent, I want to pick this one. You can also ask the agent to document the reason why not, why a alternative is not selected. Why don't you concentrate on the pipe, the underground pipe for cable conduit? Why just the residential sewer lateral? So later on, when you make further changes, you can always refer back. And then you maybe make a second decision regarding who's your main customer or whom you want to sell this product. In this case, a general contractor. The third decision you make is you want this product to have enough autonomy because there might not exist a wireless communication for you to control the robot. And you maybe by talking to your contractor, maybe you know that they are interested in same day fixing. Maybe they don't want to record the video to an SD card and have a human do the manual check later on. That's the reason why you want to some kind of onboard AI capability. And at the end of the day, you as an engineer, you reach the conclusion that you want to build a product to fulfill this niche market, the user needs in this niche market. And once you lock down your decision, which is the pipeline has to be small enough, less than 100 millimeters in diameter, have self-driving capability, and must have onboard AI for damage detection, you can actually start to write it down requirements. So this is a moment where these requirements will show up. But you can't jump directly from the user needs, which is ambiguous, to the requirements without going through this process. This is where the agent can help. So maybe one requirement can be regarding the size of the mobile robot, thus the size of the PCB who actually control the robot. And maybe the requirement could be power regarding the number of hours of untethered operation, because they need to run within the pipe. You cannot touch it, and there's no communication. And because you want to have onboard AI, then maybe you need to the board, the PCB board must have a computing unit to run some AI model for damage detection. And also there could be some other requirements related to regulations. So to summarize, as I want to address again, the agent is very helpful, very powerful. It can help you synthesize literature, get a deep understanding of the market, of the customer. It can also provide a lot of evidence to help you build a confidence for decision. It can also propose a solution as alternatives. However, you as an engineer is still the ultimate. You are still the boss, the problem owner. You still need to make your decision. This is why I'm saying this stage is probably the least place where the AI agent can substitute the human. So that's all for today. Thanks for watching.